We will be discussing magnetism in this chapter. First, we will introduce what is magnetism, what is magnetic field, how magnetic field apply force on moving charge particle and currents, and then we discuss how moving charge produce magnetic field. Let's first start with a brief introduction to magnetism.
Two like poles of a magnet repel each other, while the opposite poles of two different magnets attract each other. With powerful magnets, these attractive and repulsive forces can be quite strong. Surrounding every magnet exists what we call a magnetic field. This magnetic field always exists in closed loops around the magnet, coming out of the North Pole and extending and entering into the South Pole. As the magnetic field extends throughout space, it exerts a magnetic force on certain materials that are able to be magnetized. It then attracts those materials. The magnetic field is ultimately a quantum mechanical effect that comes about from the alignment of electrons and their spin axis in a magnetic material. Learn algebra through calculus, physics, chemistry, statistics, engineering, and more. Two like poles.
So now let's summarize what we learned. Magnetic field, just like electric field, is a field quantity that exists at every space-time point surrounding a magnet. And it's a vector field quantity, which means at every location of space and time, there is a magnetic field which has a direction, magnitude, and of course unit. Its direction is given by the direction of a north pole of compass needle pointing in that location. Magnetic field then is a good way to show how the field orientated and traced out by a compass would look like. So this is a typical magnetic field then generated by a magnet bar. So if we put a compass at every location of the bar, the direction of the needle will give us the direction of magnetic field at that location. This is how we visualize magnetic field using iron dust for bar magnet. This is what it looks like for unlike poles. This is what magnetic field then looks like for like poles. So there is similarity and also difference between magnetic field and electric field. An electric field surrounds any electric charge. A magnetic field surrounds any moving charge. So we can also produce magnetic field from magnetic material. When moving through a magnetic field, a charged particle would experience a magnetic force. We'll discuss this magnetic force in the just like we can define the strength of electric field through the full electric force received by a test charge in electric field. We can also define the strength of magnetic field from the magnetic force received by a test charge particle inside the magnetic field. Now for magnetic field, its strength is defined as force received by a test charge divided by charge, velocity, and sin theta. The theta would be the angle between the velocity of the particle and the magnetic field. The SI unit for magnetic field is Tesla. So to help you memorize, I think you can remember that the unit for magnetic field is the same as the car maker Tesla. 1 Tesla also equals 1 Newton per amp times meter. or Newton per coulomb meter per square second. It can also read as Weber per meter square. In the CGS unit system, the unit for magnetic field is Gauss. 1 Tesla will be equals to 10,000 Gauss. And this is the typical magnetic field value. For a strong superconducting laboratory magnet, it generates magnetic field of 30 Tesla. The medical MRI unit generates about 1.5 Tesla magnetic field. The bar magnets we play around with only generate 0.01 magnitude of magnetic field. All the unit we use is Tesla. The Earth generates a magnetic field which is 0.5 times 10 to the negative 4 Tesla. And the human brain can also generate magnetic field. Its strength is 10 to the negative 13 Tesla.